Hello, and thank you for joining us on MCS TV. My name is Catherine High, and I teach 5th grade science at Sally Humble Elementary. And today we are going to be comparing the states of matter. Before we begin, I'd like to review matter. I know you all have heard the terms liquids, solids, and gases, but I want us to remember that matter is all around us. You are made of matter. The device you're watching this on is made of matter, and even your dog is made of matter. Matter is defined as anything that has mass and takes up space. The amount of space matter takes up is its volume. So for example, when I pour a glass of water, the amount of space my water takes up is my water's volume. Matter can be found as liquid, solid, and gas, and that matter is made up of tiny particles that are so small, and we're going to zoom in on those later. Let's start by talking about, now that we've reviewed, let's talk about solids. Before we do that, we're going to be comparing matter based on 4 properties. We're going to be looking at shape and volume. We're going to be looking at compressibility, which means can I put pressure on these particles and make them smaller? We're going to be looking at, is the matter fluid, which means it flows easily, or is it rigid? And does matter fill its container completely? So those are the 4 properties we're going to be using to make our comparisons. Let's start with the first one, fixed shape. And we're going to start with solids. I brought some solids with me today. I have these boxes. I brought this rock, and I brought these marbles. And let's look at that. Do they have a fixed shape? Well, the answer to that is yes, because the space that these solids take up does not change. And we can use math to calculate the volume of these solids. For example, if I wanted to calculate the volume of this solid, I would take all 3 sides. It would be the number of sides to the 3rd power. My next property is compressibility. Remember, I said being compressible means you can put pressure on a solid and squeeze it into a smaller space. I'm not having much luck with this cube or this rock, and I'm going to try these marbles. You've probably all had one of these at home, a medicine dropper. This is just a bigger one. I'm going to drop these marbles into this medicine dropper, and I'm going to put a lot of pressure on them and see if I am able to squeeze them into a tighter space. And if you look, I'm not having much luck. That brings us to our next property, and that is the matter fluid or is it rigid? Well, if we look here, rigid means something's kind of stiff, and fluid means that something flows really easily. Well, this box is pretty stiff, and this rock is pretty stiff, and my marbles were pretty stiff, so I would say that solids are definitely rigid. They do not flow very easily. Now, that brings us to our last property. Does this solid fill the shape of its container completely? Well, let's take a look. Dropping my rock inside this box, it certainly doesn't fill it completely. And as you can see, the volume doesn't change. So no, solids do not fill up their containers completely. So let's summarize. We know that solids have a fixed shape and a fixed volume. We know that they're not compressible and that solids are rigid. And they also do not fill the shape of their container completely. Let's move on to liquids. My first question, we'll go back to volume and shape. Do liquids have a fixed volume and shape? And I'm going to answer both of those questions with one simple experiment. I have a measuring cup full of water here, and it has 100 milliliters of water. And I am going to pour or transfer this water into each of these containers. Now, I want you to pay close attention to the shape and to the volume. Remember, we have 100 milliliters. So let me pour it into this flask, this water. Okay. And now I'm going to transfer the water into this jar, which has a different shape. And now I'm going to transfer my water into this even bigger jar. And finally, to this beaker. Now, what was my starting measurement on the water? It was 100 milliliters. And what is it now? It is still 100 milliliters. So, liquids do not have a fixed shape, but they have a fixed volume. Our next property was being compressible. Are liquids compressible? Well, I'm going to squeeze this bottle of water. It's half full. And if you look, the water is going up, but am I really compressing the water? No. What I'm really compressing is the air inside the bottle. But it's pretty easy because there's so much air in here. Now I have the exact same type of water, and I have to really, this bottle is full, and there's not very much air in there at all. I really have to put pressure. And as you can see, I'm not really able to compress that water. So no, water was not very compressible. Now my next question is, are liquids fluid or are they rigid? Well, remember, fluid means they flow really easily. And as we watched in this demonstration, water flows very easily. So yes, liquids are very fluid. And do liquids fill the shape of their container, which is our final property? Well, as you saw here as well, the liquids will take up their own volume, but they don't necessarily fill their container completely. So let's summarize what we've learned about liquids. Liquids have a fixed volume, but they do not have a fixed shape. They're not compressible, they are very fluid, and they take the shape of their container. Now let's move on to gases. So let's talk about gases now. We're going to use those same four properties. Do gases have a fixed shape or volume? Well, gases are pretty interesting. They do not have a fixed shape, and they do not have a fixed volume. Do you have a little brother, and when you sit on the couch and watch TV, your little brother takes up as much room as he possibly can? That is how gases act. They take up as much room as they can. Now, I have a closed jar, and it's full of air. If I take the top off this jar, all of the air particles that are in here are going to expand to fill whatever container they're in. So the volume of air is equal to the volume of the container. So right now, if I figured out the volume of this container, I would know the volume of the air I have in it. Now, are gases compressible? We're going to use one of my favorite things to play with, bubble wrap. I love bubble wrap. But bubble wrap is just plastic, little bubbles with air inside them, and they help cushion things so they don't break. Well, I took my bubble wrap and I took one bubble right here, as you can see. And this is a closed system. It's got a certain amount of air in there. So if I squeeze on it, you can see no air is getting in and no air is getting out. And I'm going to go back to my syringe again. Now, I'm going to, just a simple syringe, I'm going to put it together. You know how they work. I can draw air in and I can push air out. Now, that's an open system. If I put my thumb on the end of my syringe, whatever air is in here and no air is getting out. But air and gas, which is a gas, gases are very compressible, and I want to show that to you now. So I'm going to take my bubble. This was a super fun experiment from our Great Minds curriculum. I'm going to take our packing bubble, and I'm going to drop it down in the syringe. And I'm going to put the plunger back in the syringe, okay? And I'm going to push my little bubble down. I'm going to draw back. I'm going to put my finger over the end of my syringe so that I have made a closed system. So no air should be going in and no air should be going out. And I want you to take a look. As I compress this air, what happens to my packing bubble? Can you see? I'm going to pull the plunger back so you can see that it's not the plunger. It's actually the air being compressed into a smaller space. Now likewise, if I draw back on my plunger and I give the gas particles, the air particles, more room, look what happens. They will expand to fill whatever space they can have. All right, are gases more fluid or are they rigid? Well, the term fluidity really applies to gases and liquids. If I were to open this jar, in fact, I'll do that, and I'm going to pour the air in this jar out into this room. Can you see that air pouring out? No, because air is colorless. But if this were a colored gas, you would see that that gas would flow just like water out of this jar. So gases are very fluid. And then, do gases fill up their container? Well, this is one of my favorite experiments to do. Now, you wouldn't do this at home without an adult's help. And it just requires a little bit of baking soda, some vinegar, which I have already poured, and an old film canister. We don't even hardly find these kind of this kind of camera film around anymore, but I love these canisters. Now in this canister, I have put a little bit of vinegar, and the rest of the canister is going to have air in it, okay? Now, to create more gas, I'm going to have to create a chemical reaction. So on this little piece of tissue here, I have put some baking soda. Now I'm going to make a little baking soda packet. And the purpose of the tissue is really just to give me a few seconds to get the lid on my canister. Now, in just a second, I'm going to drop this packet into my baking soda into my vinegar, and I'm going to put the cap on my film canister tightly. And that's going to create a chemical reaction. And that chemical reaction is going to produce gas. And those gases are going to go crazy, and they're going to want to take as much space as they can get. Let's make a prediction. What do you think is going to happen when I drop my baking soda into my vinegar and close the lid? Is the baking soda and vinegar reaction going to just ooze out of the side? Or is it going to bubble up and then die down because it can't go anywhere? Let's see. We're going to stand back and watch those bubbles go. Wow. So as you can see, those gases, they had so much energy and they were going like crazy trying to fill all of the space that they can fill, that they pushed the top right off my canister. Let's update. Let's just review what we've learned about gases. Gases have no fixed volume and no fixed shape. They are very compressible and they're fluid, and they will fill their container completely. So to really understand them though, we really need to zoom in on the particles. And I want to talk to you just a little bit about the particles. Remember, we said matter was made up of tiny particles, so small we can't even really see them. I want you to do this at home with me. I want you to take your hands and I want you to take your fingertips. And we're going to pretend that they are particles of matter. And we're going to model what's going on, the behavior to compare liquids, solids, and gases. Okay, now first we're going to be solid. So I want you to take your fingertips and I want you to put them really close together. Because in a solid, the particles are really strongly attracted to each other. That's why I had to work so hard to try and change the shape of that solid over there. And there's not much distance between those particles. They're really close. And even though it doesn't look like it, they're moving a little bit in place. So if you remember from 4th grade, y'all learned all about energy. So energy of movement is kinetic energy. So there's very little kinetic energy going on. Now, if I was a liquid, my particles, again, we're going to use our fingertips. My particles are going to be a little further apart. So there's going to be a greater distance between the particles. There's not going to be as much attraction, but there's going to be a little more movement. That's why those liquids are able to, those particles can slip and slide past each other to change shape. Now, if we're gases, I want you to make your fingers go wild, because gases move around like crazy. There's a lot of space between gases. Just think about the room that we're in. We couldn't walk through a solid the same way we could walk through a room. That's because the particles are so spread out. So there's a great distance between particles. There's not very strong attraction, but there's tons of kinetic energy. So let's apply what we've learned. I have a few questions for you. We talked about these characteristics of matter, and I have here a sponge. Now, is a sponge a liquid, a solid, or a gas? You're right, it's a solid, but it's compressible. And I thought we said that solids were not very compressible. So how am I able to compress this sponge into my hand? Well, I'm going to give you a hint. I want you to look really closely at this sponge. And do you see all of those holes in there? What do you think is in those holes? That's right, it's air. So am I really compressing the solid, or am I compressing the air? That's right, I'm really mostly compressing the air. This is true for a marshmallow or a cotton ball as well. Okay, I have another question for you. I have some salt here. And we know salt is a solid, our brain tells us that. But I'm going to pour my salt into this cup. And it's pouring out just like water. And it's taking the shape of its container. So why isn't salt a liquid? Well, if you look really closely, you'll notice that the shape of the salt crystals is not changing. and there's really a lot of space between them. You'd have to zoom in with a hand lens to really see, but it's really that we're pouring tiny particles into a bigger container. And now I have one more question for you. Remember our fingers? I want you to think about water. Water is something that we can find easily in all three states. We can find it as a solid, we can find it as a liquid, and we can also find it as a gas in the air called water vapor. I want you to think about the particles that make up water. In which state would the water molecules have the most energy? Would it be as a solid? Would it be as a liquid? Or would it be as a gas? If you said gas, you're right. In a gas state, those particles have the most kinetic energy. Let's wrap it up. Today we have reviewed the three states of matter. They're liquids, solids, and gases. We've compared them scientifically based on their shape and their volume, and whether or not they're fluid or rigid. And we've even discussed whether or not they fill the container that they are in. We also modeled the differences in behaviors of particles depending on the state that they are in. I hope you've enjoyed learning a little bit of science with me today. Please come back to MCS TV for some more exciting content. Goodbye.